Hi, welcome to online lecture series on microcontroller and embedded system. I am Dr. Singaravidan and today topic is on Arduino programming for analog and digital and serial communication. The lecture number is 40 and course code is 19EEE44. On embedded system, for any microcontroller, there is a need of input to process the input data, and also the processed data will be sending as an output using some output port. The input or output will take place in two forms. One is in digital and one more is in analog. Before starting, what is digital input and what is analog input or digital output or analog output? First we will see what is a digital and what is the analog. All the digital signal which is applied to a microcontroller will have a logical status information about whether it is a on or off. In other words, whether it is a high or low, or even the voltage level will indicate whether the status is high or low. So what is the voltage range for high is, it may be 3.3 or sometimes it will be a 5 also, and for low it is 0. Same way the analog input and output also will vary, not in static manner but in the continuous manner from 0 to 5 volt. So the analog input or output will take place in A0, A1, A2, A3, A4, A5 in the microcontroller, and all this the digital will go in D0 to D13, and in mega it will increase some more pins. That is having some more pins also. Now let me see what are all the different form of input, digital inputs we can able to give to the Arduino. One is using this push button. We can able to give the digital input, or any selector switch, push button, relay contact, or any other etc. Like that, we can give some digital inputs. The main aim is the digital input should have only two type of voltage status, whether it should be a 0 or it should be a 3.3 volt or even 5 volt also. Now let me see a small demonstration how we can able to produce the digital input. For that I am taking one push button here and one resistor. That's all. So the power supply which is available here will be 5 volt and one more is ground. Two terminals are there. So this 5 volt I am directly taking to the push button, and this resistor is connected to this any one of the ground. There are two grounds available here, so any one you connect, just connect it. And I'm going to check how much voltage I am getting from this push buttons. For this I am taking a multimeter and I'm converting this multimeter as a voltage voltmeter. Okay, now let's check what is the status of this. So I'm connecting this ground to here and this to the output. So when start simulation, you can see that there is a 0 volt available because I didn't press the button. So if I press the button, it's going to 5. So by this way I can able to generate a push button with sending the value of a digital signal to the board. So if I connect this positive terminal to any one of this pin, it will be taken as a digital input, because when the push button is not pressed it is 0, and if I start to press it, it's going to 5. So by this way I can able to give some digital input to Arduino board. So this is one tip for you to design some digital input signal. Now we can see a demonstration by using a push button and LED. The aim of this demonstration is, if I press the LED, if I press the push button, the LED should glow, otherwise it should not glow. So this is a type of digital input and digital output system. So let's start this demonstration. For this, let us have this multimeter so that we can see what is the voltage range we are feeding to the pin. So let's see. Okay, let's see the code first. Then we will come to the project, hardware project. Here, in last video we have seen only two functions. But one is a void setup and one more is void loop. Here there is something outside these two functions. There are three line of code is there. What is that line is? we can able to define some variable name outside the loop or outside the setup. So here they are giving a variable name called button, and the data type is integer, constant integer, means it will not change in while doing any programming. So they are given in a constant integer, and they are given a name called button. What is that button is equal to 2. So whenever I am calling this button, this name button, it means that the value is 2. And one more thing is that they have given LED is equal to 3, and here the small tip is the button button is a case sensitive. Whenever you are calling this button should be capital letter, then only the 2 meaning will come, otherwise it will take any other meaning, and it will show some syntax error. So why this name they are given is, previously we used this pin mode, directly a number we are given. What is that number? This 2 directly we will give here. Instead of that, they are given some name to this 2, so that it will be meaningful when you are writing code on the loop. So it is always better to use some variable name for the pin number, so that it will be easily understand while writing some codes. So they have given button 2, means this push button they have given in the pin number 2. So same like that, I am going to give this pin number to the 2, second pin. So now my digital input, whenever I am pressing here or if I am not pressing here, this high and low value will go to pin number 2. So what next is, so definitely it is a input, so the status is input they are given for pin number 2, because the button is written here. So the pin mode button comma input means the second pin is the input to the Arduino, and what is 3 is LED. So this LED, that is the third pin of this Arduino, is definitely a output, because they are going to write the program for this third pin to connect the LED. So let's check what is the while loop, what is the main program they have written to continuously execute. So button status, so again they are calling some variable which is declared here on the integer, and this is not constant, because this integer status will change to high to low value anytime. So the button status they are given as 0. Initially the value is 0, but it will change when the input is taking into the Arduino. So what they are telling is, this button status getting the value of digital read, means the digital status of button. What is button is pin number 2. The status of pin number 2 will read the digital status and stored in button status variable, which is given by us. So you can give any name according to your logic. Here they are given button state. Okay, so meaning that the status will be stored here, and this status, what that button status should do is, so if button status is equal to high, so they are checking if condition. So if condition you are learning here in this video. So if condition is, if the button state is equal to high, means if the pin number 2 is high, then digital write LED high, means here the digital write of LED. So LED is pin number 3. The pin number 3 will get high, else otherwise the digital write LED is low. So what they have written is, it will look the status of the pin number 2. Accordingly, the pin number 3 will send digital output. So button is digital input and LED is digital output. So they're playing with this. So whenever I am pressing the button, the LED will glow. So now go to the hardware and I'm trying to connect an LED. So LED on pin number 3, right? So I need a resistor to protect the current, and this ground will be connected directly. There is one more ground available on the top layer, and I'm going to connect this and here to the pin number 3. Now the hardware circuit is connected. Now just try to run the simulation. See, you can see that the digital input is 0, so the LED is also not glowing. If I press the push button, the LED is glowing. You can see that LED is glowing there, and it is off. Because of the processing speed is very low in the laptop, it is taking some time. In practical, because of your physical pushing on the button, it will immediately respond when you stop or when you leave the push button, and immediately the LED also will stop. Because of the processing speed delay, making some delay, because the browser has its own speed and my processor has its own speed and internet speed also. So it is taking some delay, otherwise it will be very fast glow and off. Now we'll see some serial communication also. Say for example, if you want to send the status of the LED, whether it is on or off, in a serial port, or you want to communicate with some other Arduino or some other computer, the communication mode will be mostly serial communication. So in this Arduino already serial communication is available. So just see how we can able to code the serial communication to send the status of the LED button. Let's check how the code will work. So just go to the code. Here I opened a serial monitor. It is below in this text. On the bottom of the text you can see a serial monitor. Just press this serial monitor, you can see what are the serial information you are transmitting from the board to the serial port. So before that we will see how the coding is. So to start the serial communication, you need to begin the serial port within the setup. So here you can see serial.begin 9600. So this 9600 is the baud rate we are fixing, because most of the computer or any other microcontroller they will use 9600 baud rate only. So by default we can give 9600 for communicating with all other universally, right? So first you need to begin the serial. First step to start the serial communication is inside the setup serial.begin. First step. Second step is what information you are going to transmit to the serial, right? So here already we are having this code. In addition to that, just I entered serial.print ln inside the bracket the status, button status. Already we are reading the button status in this line number 14, and in line number 18 we are just sending that status in serial port. Here without this ln also it will work, but this ln will print the serial port in line by line. Otherwise it will come in adjacent, so you can't able to see the variation of the status with respect to different time. So and both side I have given, not only in positive condition, in negative condition also. If else also I need to send the status. So two places in line number 18 and 22 I have given the same code. So just adding this serial code in setup as well as the loop, we can able to transmit the information or communicate the information through the serial port with any other devices. Let's check the code. See for example, okay, I will start the simulation. Okay, you can see the status is going 0 now, and if I press the button, you can see the status is changed to 1 in serial monitor. By this way, if I connect this serial COM port to any other COM of your computer or even in another microcontroller, if another microcontroller means just connect the serial port, receiver port from this transmitter and receiver, so this information will be transmitted there. So this is a small demonstration to learn the serial port. Suppose if I want to send some meaningful information in the serial, for example, instead of sending the status, I want to send something like serial print LED is on. If it is on, so is on. So if it is off, then LED is off. So now we can check. You can check the letters showing here LED is off, because the LED is off air and the status is sending in serial, and if I just press on, you can see LED is on, and it is going very fast. So if I want to make some delay here, I just call a delay function here, delay for quarter second, 250 millisecond, and just copy and paste it. Now let's check. It's going in little delay, so I can check clearly what is the status of my LED. So to communicate from one device to another device through serial communication, we can use this. The serial communication will be easily connected to any wireless devices also, such as Zigbee or Bluetooth or any other wireless communication which is available in the embedded market. So easily we can able to transmit the serial communication port into that wireless port also. So it is always better to learn how to deal with serial communication, so that you will be mastering in wireless communication or any other communication mode also. Now we can see how to send the analog input to Arduino. So to send the analog input, we can get it from any sensors or any sensors like potentiometer, temperature sensor, or CO2 sensor, pressure sensor, humidity sensor, flow sensor. There are many sensors available in the market. So if you want to deal with these sensors, or if you want to get some information from this sensor, you need to understand how the analog is working on the board. So in this demonstration, we are going to see a analog input by connecting a potentiometer. This potentiometer can vary from 0 to 5 voltage as per the maximum minimum limit, voltage limit what we are giving. Accordingly, we can able to vary the voltage range. So we are using this potentiometer as a analog input, and we are going to demonstrate how we can able to code the analog input or process the analog input and get some useful output for that analog input. So I am going to take one potentiometer here, and this potentiometer range I am giving from 0 to 5 voltage. So one terminal of this I am going to give in 5 volt, and one more terminal, that means terminal 2 I am going to give in ground, and this wiper is my input. So this input, before giving input to my Arduino, I want to check how the voltage is varying. So I want to check the voltage range. So I'm going to connect a voltmeter here. So I'm just finding where is the voltmeter. Yeah, it is multimeter. In this multimeter, I can able to check the current, voltage, and resistance value. So I'm not going to test even though it is a part, I'm not going to test the resistor, but I want to see the voltage range, varying range. So I make this voltmeter, multimeter as a voltmeter. So I'm going to connect the negative. So already negative is connected in this terminal 2. So I'm going to connect this terminal 2, and in wiper I want to measure the voltage. So how the wiper is varying my voltage, and how I can able to give this wiper variation into my analog signal. So without writing any code or connecting any connections, just I want to measure the analog input. For that, I just connected a simple circuit and start the simulation. And you can see it is a 5 volt. That is a maximum voltage because the knob is at the maximum position. So I'm just trying to vary the knob. So you can see from 0 to 5 volt, I can able to vary my input voltage. So it is good to go with this analog input to give some inputs to the Arduino Uno. So with this setup, I'm going to give my analog input to the Arduino Uno on analog pin 0. So this wiper button I'm going to connect. Okay, before that I want to stop the simulation. Okay, so anything if you want to change your circuit or add some circuit on your project area, just you need to stop the simulation, then only it is possible to connect anything. So this wiper button I am going to connect with my A0. So now I connected my analog input varying from 0 to 5 to the analog 0, that is A0 pin of my Arduino Uno. So now the input is given to the Arduino, then what I want to do is I can able to control something or process this signal and do some useful work. So in this demonstration we are going to vary the DC motor speed, 5-volt DC motor speed, by varying my potentiometer, means part. So according to the signal, analog signal which I am generating on this part, with respect to this signal my motor speed going to vary. This is the very simple project I want to make. So for that I am going to search some DC motor which is available in this simulator. Yeah, there is a DC motor available here, so just drag and drop this DC motor here, and this is the terminal 1 which is positive. I am going to give this positive to my pin number 3 because I am making this pin number 3 as output. In upcoming code I will show this, and terminal 2, okay, this is positive because it is red color, so it is positive. This positive I am going to give in terminal 3, and this negative I am going to give in ground. So I have connected the pin number 3 to my DC motor, and I have connected A0 to from my analog input. So this is the hardware circuit, just simple hardware circuit. For this our aim is, with respect to my potentiometer signal, the motor speed should vary. So this is very simple aim, and also I want to transmit the potentiometer voltage level in my serial communication, because suppose if you want to send the signal of your analog signal to any other microcontroller or computer, you want to transmit their signal into the serial port. So three things we are going to do. We are going to get the analog input from A0 and process that analog signal, and we are going to send the speed control of the DC motor, and also we are going to transmit the analog value to another computer through serial port. So this is the three aim of this demonstration. Just I am going to start the code now, and you can see in code there is little variation from the last code. Here what I did is, the LED is constant, no issues. The LED is 3, means instead of LED we are connecting motor, no issues. You can change your name, own name, because this is the variable name, you can give anything. And this A0 I have given the value as analog IP, means I have given this name, you can give your own name, means I am meaning that this is the analog input I am getting from A0. And void setup, analog IP as I given as the input, because this analog this analog A0 is the input for me, so I am giving this analog IP as input, and the LED is output because I connected my motor, so this LED is output. And I want to share something in serial, so I want to begin the serial, so I given this serial. So all these three setup has been done in the setup function. Then very simple code is, I am going to read the analog input. So analog read. Last time we have read the digital. Here you can see this is analog. So I am just reading the analog in analog pin. Analog pin, where is the analog pin? Analog pin is A0. So analog pin is A0. I am reading this A0 value, and I am storing that value into analog IP value. You can give your own name, no issues. Analog IP value. Okay. So one more point you want to note here is, in global I didn't declare this analog IP value, but inside the loop I have declared by indicating the data type for this. So integer analog IP value I declared in loop, not in global. So you can't able to use this analog IP value in any other functions. So only inside the loop function we can use this analog value. If you want to use in many places, then you need to keep declare that variable in global. So that is a small tip here. And the main thing is, see, the analog value what we are feeding into A0 will not read as voltage. It will read in the value of in the value of floating point from 0 to 1023. So this is the maximum value you will get if you vary the knob from 0 to 5. So how we can able to find this, I will tell, I will come later, how I calculated this formula, I will come later. It's very important formula for while if you are dealing with any sensors. Otherwise you may face many problems. In practical you will face this problem. I will come to this later. So now you assume that you are getting some value in voltage from 0 to 5 with this calculation, and you are writing this value in LED. This value you are not writing in digital, but here very important is you are writing as an analog. So if you are trying to write as an analog, then this pin number 3 will not send value only two values, that is 0 or 1, but it will send the range between 0 to 5 voltage. So this is very important, you need to note down, even though it is a digital pin, but even though we can able to send some analog signal in digital pin also. So LED pin is digital, but we are writing analog, right? So no issues. And what we are writing? The voltage. What is the voltage? The voltage is what we are getting from the analog input. So we are writing that voltage value into LED pin, and I want to check what is the voltage value. So just I am sending this voltage value into serial pin. So very simple code. I will come the line number 14. Why we come to line number 14? Before that, we will see the output, how it is working. Okay. So for that, I am starting this simulation. Just start the simulation. Okay. Now you see the serial monitor is sending the voltage range is 0, and also in the multimeter we are seeing the voltage is 0. So the motor speed is 0 RPM, and it's not animating on rotation. So I little bit increasing my voltage. So at 1.40 volt, my RPM rate is 22. So 22 at 22 RPM speed, it is the DC motor is running. And if I go to 2.5, it is increasing, the RPM is increasing, and still it is increasing if I rise to 5. So now the maximum speed we have reached here, that is 100 RPM we have reached, and you can see the same voltage value we are seeing in the serial monitor also. So by this way I can able to control the speed of DC motor by with respect to my analog signal or potentiometer. So this, instead of if you are using any potentiometer, if you are using any other sensors, like with respect to temperature, you want to control the fan speed or motor speed, that is also possible. Only thing is how we are dealing with the sensor is very important. And I'll stop this simulation now, and let I come to the line number 14. Why I have come with this formula is very important. So if you want to know the formula why I have used in here, first I want to check what value I am receiving at A0. That is very important. Whether I am directly without this formula, how it is going. Just I am going to block this line and check. Instead of voltage, if I am giving the analog IP value, let's check what is happening. Okay. So analog IP value I am copy and pasting here. Okay, and I want to check the analog IP voltage. Okay, now let's start the simulation and check what is happening here. You can see some value which is not 450, but in actual voltage is 2.2, but I am getting 450. So actually I am not getting at A0, I am not getting 2.2 volt, but I am getting 450 value. So what is happening here? Let's check a minimum and maximum value of this potentiometer with respect to how much value I am getting in A0. With that, I can able to come to a conclusion of line number 14 why I have chosen this formula. Okay, so the maximum of 5 voltage, I am getting the value 1023. So this is the maximum value I am getting at the maximum voltage level, and the minimum voltage level is 0. So now we can understand something about the analog is not getting actually a voltage value, but it's getting analog value from 0 to 1023. So in between this range the value is getting. But my aim is I want to send the value at D3 from 0 to 5, and also all the human we understand only the actual values from 0 to 5 voltage only. So for that I want to scale down the values from 0 to 1023 to 0 to 5. So this is the formula to simply scale down the values from 0 to 1023 to 0 to 5.
So here let's check the formula what is happening here. I am declaring a variable with float as a data, and I am just multiplying my actual value, whatever the value I am getting from the analog, I am multiplying with scale down factor, that is 5 divided by 1023. So this is the scaling factor, multiplying factor. If you multiply this with this analog value, we will scale down easily the value from 0 to 1023 to 0 to 5. So here now the voltage is having an actual value, whatever the displaying on the multimeter, the same value is presented in voltage. Now it is good to go to write the voltage value to send on LED. Here LED is connected to a DC motor, right? So I am replacing these values to voltage only, and here also voltage. Okay, so now I can able to operate my, now the motor is running. Previously when I feeding the analog IP value directly, the motor is not running because the values here going is from 0 to 1023. It's not a feasible value, or even that value voltage will not be generated. So it is always better to scale down your values, or it is always better to check the value what is the minimum and maximum analog value you are getting in the analog pin or from the sensor. So if you are very clear about your analog values, actual values you are getting on the port, then you can able to easily use this multiplication factor for your actual, to finding out the actual error. Sometimes you need to scale down for 10 volt, 0 to 10 volt. At that time you just replace this 5 with 10. So obviously we will get the corresponding value. And if the voltage is not between 0 to 5, but it is between 0 to 1 volt maximum voltage you are receiving from your sensor, then you need to check change this value by checking the actual value in the serial port and press the maximum value you are getting from that sensor here, and scale downing values here, and actual sensor reading here. So by this simple multiplication factor you will get exactly what you need for your particular project. So in this video lecture we have learned that what is analog input, what is analog output, what is digital input, what is digital output, and with this digital analog input and output you have learned some basic small projects, and also learned about the serial communication, how to program the serial communication, and how we can able to manipulate the serial communication with some useful information. So all these things we have covered here. This is very important which lecture series to understand the concept from very basic. So if you not get some point, you go through once again and understand. You can easily understand the concept. All the practical difficulty normally students will face, I have covered in this lecture series, and in next upcoming videos we will see some little bit more complicated circuit also. Bye.